Section 1.5 Matrix Operations. Well, remember that a matrix is, in general, a rectangular array of numbers. Matrix can be denoted by letters, capital letters, for example, A, and you say the matrix 1, 2, 3, 4, or the matrix B with 2, 3, 0, -1, 4, 5. Or something like that. Remember that, oh, by the way, remember that you can also put a matrix like with big brackets. No problem with that. So it is the same whether you use big parentheses or big brackets. So something important about the matrices that I have talked about before is that the size of the matrix. Remember that the size is measured by the number of rows and then the number of columns. For example, this one has 1, 2 rows, and it has 1, 2 columns. So we said that this matrix has size 2 by 2. This matrix has size 1, 2, 3 rows, 1, 2 columns, so it's 3 by 2. This matrix has size 1, 2 rows, 1, 2, 3 columns, so it's 2 by 3. It's 2 by 3. So other important thing about the matrices is that we can be able to identify the entries. Sometimes it's going to be useful. For example, entries so notice any entry for any matrix can be identified by the position of the entry. Is going to be determined like a coordinates by the row and the column. For example, for this matrix A, for A, as in the previous example, for example, I can say the entry A 1 1. Yeah. This indicates the number of row and the number of the column. So if my reference is this matrix A in this example, A11 means the entry in the row 1 and in the column 1. That is going to be this one. 1. I can say also the entry A22 is going to be the entry for this matrix A in the row 2, column 2, that is 4. And so on. In general, a matrix, and this notation is very useful, can be denoted by like the general entry. For example, I can say the matrix A defined by Aij, and then you can specify the size with size n by n. The advantage of this notation is going to be useful when we define the operations with matrices. For example, here, the first thing I can say equality of matrices. I can say the matrix A given by Aij and B, capital B, given by Bij are equal if and only if they have the same size and for any subscript, I mean any ij, we have that Aij is equal to Bij. So what is this saying to us? This is only saying that two matrices are going to be equal if they have the same size and entry by entry they are the same matrix. For example, one example here, solve for x. If I have this matrix 2, x minus 1, 3, and 1 is equal to 2, 3, 0, and 1. So if I'm saying here that these two matrices, that notice they have the same size, the size is 2 by 2, 2 by 2 in both. If I'm saying that they are equal, and I'm saying that here because of this symbol, then entry by entry should be equal. The entry in the row 1, column 1 here should be equal to the entry in the row 1, column 1 here. The entry in the row 1, column 1 here should be equal to this, and this one to this, and this one should be equal to this. We have entry by entry, 2 equal to 2, x minus 1 equal to 0, 3 equal to 3, and 1 equal to 1. But our concern is this one because we want to solve for x here. So this implies x equal to 1, you see? And there you have the solution for x. Now, sum and subtraction. Sum and subtraction of matrices. Given two matrices, A and B, with the same size, we define a new matrix that is given like this: A plus B is going to be equal to the matrix with the entries Aj plus Bij. So in other words, if you want to, well, this is, I use only sum, but it's the same for subtraction. So I can use here the symbol for sum or subtraction, plus minus. plus minus. So the same. So given two matrices A and B with the same size, we define the sum and subtraction of the two matrices. How? Only add or subtract the corresponding entries. It's that simple. For example, given A equal to 1, 0, -2, and 3, and B equal to 4, 3, 0, and 2, I need to find A plus B. Be careful. The addition, the sum or subtraction of matrices is only defined when they have the same size. Yeah. Otherwise, it's not defined. If they don't have the same size, then the sum or the subtraction is not defined. It's not possible. In this case, we have A plus B. We have a new matrix that is going to be only add entry by entry. This one with this one. 1 plus 4. 0 plus 3. -2 plus 0. And 3 plus 2. And then simplify. And we have 5, 3, -2, and 5. And there you have, this is the new matrix, you see? Entry by entry. Scalar multiplication. Given a real number C and a matrix A given by Aij, we define C times A. Notice here I am multiplying a real number times a matrix. Yeah, I am not using two matrices so far. This is only a matrix and real number times a matrix. How do we define that? It's very simple. When you are going to multiply a real number times a matrix, the only thing you need to do is to multiply each entry in the matrix by the real number. Example. Given this matrix A, find the scalar multiplication of 3 times A. So in this case, we're going to have a, what do I need to do? I need to multiply each entry here by the number 3. So we want to have 3, 0, 6, 9, 24, 27. And that's all. This is how you find the scalar multiplication. Now, multiplication of two matrices. This is very important. If you haven't seen this before, so pay special attention here. because the first time the multiplication of two matrices is not, I think it's not very simple. But I will try to explain this in the best possible way I can. So rather than giving a definition, I'm going to show this by examples and what is the process you need to do. Let's say that we have two matrices. Example. Matrices 2, 1, 0, and 3. And a matrix B 1, 0, -1, 2, 1, and 0. And we again, I won't give a formal definition for the multiplication of two matrices, but I will explain in detail. First, the first thing that you need to verify to perform this multiplication is whether you have to pay attention to the sizes of the matrices. This matrix has size 2 by 2, and this matrix has size 2 by 3. We are going to find a matrix that is going to be defined as A times B, the multiplication of the two matrices. So, first, the product or this multiplication is going to be possible only if the number, here, by the way, the order in which you made the product is important. Notice how I have here A times B. So I want the first matrix is A, the second one is B. The product is going to be possible if the number of columns in the first matrix, the matrix A, this one, matches or is the same as the number of rows in the second matrix. If these two numbers are equal, then the multiplication is going to be possible. Same number. Multiplication is possible. Now, this is the first thing you have to verify. If this number is not the same as this one, this multiplication we're going to define here is not possible. It's not possible. Is that okay? Next, you will have to pay attention to the resulting size to the size of the resulting matrix. This matrix A times B, let me write it here. Is going to have what size? The size is going to be, pay attention to the numbers we haven't used in the sizes of the matrices. Again, to verify the size of to verify whether the multiplication is possible, you have to pay attention to the number of columns in the first matrix and the number of rows in the second matrix. If they are the same, then the multiplication is possible. Now, the resulting matrix is going to have size this by this one, 2 by 3. So in this case, I'm going to have a matrix. The resulting matrix is going to have size 2 by 3. So that means it's going to have 1, 2, 3 columns, and 1, 2 rows. So I'm going to have 6 entries. the first entry is going to be in the row 1, column 1. This means row, this column, but it represents an entry. Then row 1, column 2, row 1, column 3, here row 2, column 1, here row 2, column 2, and here row 3, column 3. Row 2. So again, to verify whether we can perform the matrix multiplication, this number and this number, they must be the same. They are the same in this case, perfect. Now, the resulting matrix AB is going to have size the numbers you haven't used, this one by this one. So the entries are going to be, we're going to have one entry in the row 1, column 1, row 1, column 2, row 1, column 3, row 2, column 1, row 2, column 2, row 2, column 3. Is that okay? With the size 2 by 3. Now, how to perform or how to find these entries? You will have to pay attention to the row and the column where the entry is. For example, this one is in the row 1, column 1. Row 1, column 1. You will have to multiply the row 1 from the first matrix times the column 1 from the second matrix. Always this makes reference to row, the first matrix, column, the second matrix. Row 1, column 1. But how do we multiply? Notice, row 1, here's to 1, and here's 1 to the column 1. To 1 times 1, 1, 2. How do we multiply rows and columns? Very simple. Multiply the first one, the first element in the row, times the first element in the column. For example, here 2 times 1 is 2, and then plus, always plus. I mean, whatever the number is, the next number is negative, positive, always use plus. Plus 1 times 2, that is 2. In this case, 4. So row 1, column 1 is 4, you see? And so on with all the other entries. For example, next one, row 1, column 2. Row 1, column 2. Row 1, column 2 is equal to the row 1 in the first matrix, 2, 1, times the column 2 in the second one. Column 2 is 0, 1, so we have 0, 1, and we have, again, the first element times the first element plus second element times the second element. This case will be 2 times 0, 0, plus 1 times 1, 1. So we have 0 plus 1 is 1. Next one, row 1, column 3. Row 1 is 2, 1 in the first matrix, times column 3. In the second one is negative 1, 0. And this becomes 2 times negative 1, negative 2, plus 1 times 0, 0, so we have negative 2. Now the other entries, row 2, column 1, row 2, column 2. Row 2, column 1 is row 2 in the second matrix, no, in the first one, 0, 3. Times column 1 in the second one, that is 1, 2. And again, first element times the first element plus second element times second element. So we have 0 times 1 is 0, plus 3 times 2 is 6. So we have here 6. Row 2, column 2 is row 2 in the first matrix, 0, 3, times column 2 in the second one, that is 0, 1, element by element, 0 times 0, 0, 3 plus 1 is 3, 3 times 1 is 3, so we have 3. And finally, row 2, column 3 is 0, 3, column 3 is negative 1 and 0 in the second matrix, so 0 times negative 1 is 0, 3 times 0 is 0, and we have 0 here. So A times B that has these entries, only put the corresponding entries. It will be 4, 1, negative 2, 4, 1, negative 2, and then 6, 3, and 0. And there you have the matrix with size, the product AB with size 2 by 3. Again, well, I know this is a video, so you can check this process again, but it's very important again. If these two numbers, when you do the product A times B, whatever the matrix MBR, they are not the same, this multiplication is not possible. Pay attention, again, if this is the first time you're seeing this, I recommend to do it with this process. I know once you have practice, you will see that it's not very complicated, or you can do it faster. But by now, I recommend to follow this process. These numbers must be the same. Then, if they're not the same, the multiplication is not possible. If they're the same, I recommend to pay attention to the size, to the size of the resulting matrix, and then do the multiplication. Again, once you have practice, you're going to be able to do it faster. But by now, I think in this way it's enough. All right. All right, this section 1.6 is about some algebraic properties of the matrix. For example, some properties. I mean, these ones, they should be proved. They're not very complicated to prove, but I won't prove them. Instead, when we need this, some of this, I will let you know if I need to do something like a proof or something similar. I will let you know. But for example, some properties, for example, with the sum of matrices, is that you have A plus B is the same as B plus A. If you add A plus B first and then plus C, it's the same as A plus B plus C. Something similar to the real numbers. There exists a matrix, the matrix 0, matrix, such that for any matrix A, we have A plus 0 is equal to 0 plus A. So we have, again, things like that. I won't focus so much on these properties because of the nature of the course, but again, if I need more properties or things like that, I mean, because they're going to be useful for exercises on whiteboard or discussion board, I will let you know, and I will remark them with more intensity, right? But well, this section is only about this, and it introduces another operation that is the transpose of a matrix. This is a new operation. If we have a matrix A given by Aij, then the transpose is only switch the order of the rows or the columns. So we're going to have Aji. Yeah, and this way is like a little confusing, right? But one simple example will let you know that this is very simple. If we have the matrix A equal to 1, 0, 3, negative 2, 4, 5, and I want to find the transpose, then what I have to do is put the rows as columns. With the first element is going to be the first element, the second one is going to be the second one, and the third one is going to be the third one. So for example, in this case, all of this row, 1, 0, 3, put it as a column, 1, 0, 3. And this row, the second row, this one, is going to be a second column. It's going to be negative 2, 4, and 5. You see? Notice how the orders switches. I mean, the order, the size. This size for this matrix is 2 by 3. The size for the transpose is 3 by 2. Some properties. For this one is for the transpose is again. We will, if we need them, we will use them. I will let you know. But the transpose of the sum is equal to this one. The transpose for each matrix. If you have a multiplication, the transpose of the multiplication is switches the order of the matrices. Is C transpose times A transpose. And the transpose of the transpose is the same matrix. And well, again, this is a basic introduction for operations for matrices. If we need more properties or other operation, I will let you know that we are using this or that it's based on something that we have seen before. But by now, I think it's enough. So again, try to do the exercise on Webwork. If you have any question, remember you can send me an email. I will reply to. I try to reply to all the emails. Yeah, with your questions. Remember, you can also use the schedule office hours. See you.